What I'm going to be talking about is, the title is a little bit misleading, but the idea is that there are companies like Google that have amazing technology that's allowing them to work in the ways that they are working. So I'm going to be covering one of those, or an open source project that allows companies that are not Google to do some of the same things that Google's doing internally. As Jules said, I'm Joonas. I'm the Director of Engineering at DigitalOcean. I've been at DigitalOcean for about 18 months. I've seen us grown in that 18 months from about 100,000 droplets to about a little over 3 million droplets today. When I started, we had 2 data centers, and today we have 9. So we've gone from being just in Amsterdam and New York to being basically all over the globe. Actually, and just last week, a few days ago, Netcraft announced that we are the 3rd largest web-facing hosting provider, for what that's worth. So, you know, pretty exciting stuff. So recently, I've been really thinking about this. I've been reflecting on some of my time here at DigitalOcean, the 18 months that I've been here, and some of the lessons that I've learned from developing various services for DigitalOcean. I've also been observing the industry, you know, companies like Netflix, companies like Google, Twitter, Airbnb, Uber, you know, these companies are innovating very quickly. And there are certain things that they're able to do that many of the companies, smaller companies, are not able to do. So I've been very curious about what is it that is allowing these companies to move at the pace that they're moving. You know, I've sort of learned from experience that problems at scale become a lot harder than they are at, you know, when you're just a few servers. So I've been very intrigued by the things that have allowed them to basically innovate so quickly and allowed them to succeed in the marketplace. So I started looking into that. But some of the challenges that I've certainly experienced throughout my career as a developer, we have, you know, Snowflakes in our infrastructure, and I'll describe what a snowflake is in case you're not familiar. We have hardware and software failure, no matter where you run, except for maybe a mainframe, which most of us probably can't afford. And then, you know, once we actually hit it big time, or we become relatively successful, scaling these services that we build is actually pretty hard as we are re-architecting our infrastructure. So Snowflakes. So Snowflake servers are basically things that somebody has, you know, back in the day, configured by hand just because we needed to. We needed to get it out there. We needed to get it out there quickly. And then we had it doing its job, and then we kind of forgot about it. And then one day, something business critical goes down, and everyone's like, what happened? And then it turns out you have a server that nobody knew about, or the people that knew about it forgot about it, and, you know, we no longer are able to run that business critical thing. And then, you know, when it comes to operations, and when it comes to, you know, when we discover this thing, we're like, well, how do we actually fix this? And we have great software today, things like Chef and Puppet and Ansible. These things can really configure your servers to a state that's known and you can understand, but the problem is you don't know what the configuration was or the work that went into it. You have no idea. So, you know, they're finicky. Here's an email that I've received back in August from us, of all people. It's telling me that the server that my droplet was running on used to have maintenance performed on it. And I'm sure that if you're running on AWS, you've seen their version of this, which says, hey, the server you have is going to go away. Sorry, you're SOL. So this stuff happens. And so I read this paper published by Google, and one of the things that kind of jumped out at me was this statistic, or this description of disk drives. So they're failing at the rate of 4% every year. But then the second part, these servers that we're running our infrastructure on can be restarted at up to 16 times a year. That's a lot of times a year, especially if you're trying to keep your service running. So, you know, this got me thinking about things. Then finally, when you start getting some traction for your server, or service, Maybe you started out with a monolith. You have a single application. You have a database, and that's all. Everything's great. Then all of a sudden, traffic hits. You get put on Hacker News, or you get slashdotted for the old school people, and you start realizing that whatever monolith you just had is really not going to scale. Or maybe your needs evolve. You need cron jobs. You need stuff that runs in the background. So you start branching out. Well, over time, coordinating this mess becomes really, really complicated. And even though we have great tools for that, like Chef and Puppet, those things are not that easy to configure to work very well with these things. So, and most of all, is this really the thing that you're in business in? Are you in the platform as a service business? Probably not. So why should you be doing that? So I read this paper, or came across this paper from Google called The Data Center as a Computer. This is, I think, from 2009. And one of the things that really intrigued me was when they were talking about cluster-level resource management. And I should have highlighted the parts that really jumped at me. But basically, they're talking about how you can abstract your computer, the server that you have, away, and you deal only with the resources that are provided by the server. So that, to me, sounded like something that I would really like to get into, because I don't really care about the servers. And this is really the way that Google has been doing it for a number of years now, probably over a decade. So if Google's doing it, why can't we be doing it? We should be. So what this would require you to do in order to really start applying these patterns is you should start thinking in terms of services instead of servers. Because do you really care about where the application runs? Probably not. But you care about the fact that it's available. That's the only thing you care about. So why would you care about where it's running? Also, you should be thinking in terms of resources instead of servers. Do you really care, again, do you care about the fact that it's where it runs? Or do you care about the fact that you have the resources to run this thing somewhere? You shouldn't really care. So what I came across was this fun little thing called Mesos. Mesos was originally modeled after a thing from Google called Borg. Borg is basically a cluster manager, which you give it something, and it'll just put it somewhere and run it. That's all it does. So in a little bit more detail, Mesos basically abstracts the CPU, memory, storage, and other resources from the underlying servers. So whether they're physical, bare metal, doesn't matter. Mesos can run on top of it, and it'll just provide you the resources. And that's basically what it allows you to do, is allow you to build fault-tolerant and elastically distributed applications. And I'll get into a little bit how that actually works. So I'll talk a little bit about the architecture of Mesos. So Mesos is basically made of a master and a slave process in sort of all in its glory. Then on top of that, we have what they call frameworks, which in this case is, for example, we have a Hadoop scheduler. So a framework is made up of two pieces, a scheduler and an executor. And the scheduler lives outside of the framework, outside of the slaves, and the executor lives on the slaves. So what happens is, backing up a little bit, on top of that, you also have, the way Mesos provides fault-tolerant services is it has a Zookeeper quorum running next to it or somewhere that it talks to, and then it has a couple of other masters that are on standby. So what happens is if you lose one of the masters, the other masters will notice that, and through the use of monitoring on Zookeeper, and they'll just take over. So they'll basically perform a leader election. And what's really nice about this, this is a very, very simple model. What's really nice about this is the way it works is these slaves that you have are basically, they have what they expose the underlying server resources. So in this model, you can see where you have the circle number 1. The slave number 1 that we have is telling the allocation module on the Mesos master, hey, I have 4 CPUs, 4 gigabytes of memory available. What then the Mesos master does is it tells the framework that has registered itself against the master that there's a slave with the resources available of 4 CPUs and 4 memory. And these are called resource offerings. So what the frameworks can then do with their scheduler is say, well, I'm going to execute a couple of jobs. In this case, in the circle, on the one that's labeled 3, the framework has scheduled 2 tasks, one with 2 CPUs and 1 gigabyte of memory, and another one with 1 CPU and 2 gigabytes of memory. And it's basically telling the Mesos master to basically send these tasks down to the slave. And then in the 4th one, it's basically the Mesos master is telling the slave and ultimately the executor process, which lives on this slave, to execute these 2 tasks that the framework told it to execute. And so you can see the 2 dotted boxes with the word task in there. They're basically sandbox processes that are just being run, executed by the processor, the executor process. And so, you know, we're used to having like static allocation of resources on a given host, where you might start a process on a host and it just keeps on running there indefinitely. And that's all great, fine, whatever. But the reality is a lot of times we're way underutilizing our resources on any given server. So what Mesos allows you to do is basically the slaves or the cluster nodes can tell you, or can tell the master, like, hey, I have way more resources available. You can still, you know, you can utilize these. And you could run a bunch of different stuff on there. On top of having that process running, maybe you can run some batch jobs, maybe a distributed cron job, things like that. You know, so you can make use of that, better use of that resource that's available on the slave. And then we can get into some of the frameworks. So, you know, we've talked about the Mesos master and the Mesos slave. And really what makes Mesos interesting is the frameworks. So the frameworks are basically applications that are built to leverage the Mesos cluster manager. And there's a number of these. So I've took this picture from Mesosphere's website. It's basically, they categorize the different frameworks or the applications. They keep changing the words, but I think they're called applications now. There's basically 4 different categories of applications here. So you have the sort of long-running processes, Aurora, Marathon, SSP. Then you have some big data processing. You might recognize some of the names, Hadoop, Spark, Storm. You have some batch scheduling stuff, so cron jobs or Jenkins. And then you have some data storage. So you can scale your, let's say, Cassandra cluster or Hypertable or Elasticsearch cluster without having to worry about it, without worrying where it's running, basically. So these are basically the 4 different types that you could be doing. And there's also, you can build your own custom frameworks. That's where things get really interesting. You can do all sorts of stuff. This is also missing a few of the more recent frameworks like Singularity from HubSpot, which is their own framework that does a combination of all these tasks, basically. So here's a diagram to kind of put it all together. So you start out at the cluster level. That's where you have your servers, you know, all the resources, and they're just clustered up with the nodes. You have a distributed file system, which is basically what Mesos uses in order to pass things around. You have Mesos, which is sort of the kernel of your system. You have on the side, you have different languages. You can language bindings, so you have C++, JVM or Java, Python, Ruby. There's also Go, apparently Haskell and Erlang as well. And then you have the frameworks. So you have Marathon and Chronos. And actually, an interesting thing about Marathon, and wow, those colors are terrible on this screen. Marathon is considered like a meta framework, which means that some of the other frameworks can actually run on top of Marathon. So in this case, the Chronos could be running on Marathon, or all the other stuff could be running. So because it's just another process. And then as you move up the level, you have apps. So you can be running like Django, Rails, JBoss, Kafka, you know, all these other things. And the spectrum that these are on is like you start with, on the left side, with the batch jobs or batch processes, and then on the right side you have services, so something that might be more long running. So you might be asking, all right, or you might be thinking, so that's great, but how can I make any use of this? And why, more importantly? Well, so Adrian Cockcroft, he's previously a cloud architect at Netflix, and today he's a technology fellow at Battery Ventures. One of the things he puts up one of the first slides he always puts up on his presentations is the lessons he learned while he was at Netflix. What I like to think about these is these should be the kind of guiding principles that we should always be building our applications and our infrastructure, more importantly, our infrastructure with. So, one of the things they found out at Netflix, and one of the reasons why they've been so successful is that they realized speed wins at the marketplace. So they've allowed them to innovate as quick. They've tried to provide themselves an infrastructure and a framework how they can innovate as quickly as possible because speed wins in the marketplace. They're looking to do things like remove friction from the product development. And one of the things you can do with something like Mesos is you can basically give your operations people can provide your developers or engineers a self-service platform with something like Mesos. High trust, low process, no handoffs between teams. Again, if you have something like Mesos, you can just ship your application into it and it'll just take care of the rest. Freedom of responsibility, again, if you ship something, it breaks, kind of playing into what Ron was saying, if you ship it, it breaks, it's on you. Don't do your undifferentiated heavy lifting. Like, this is a very complicated, well, relatively speaking, complicated piece of technology. Why would you be building something like this? Everyone seems to be building their own deployment systems. And, if you have a really good reason, sure, but most of us don't. This is one of those things that we just don't need to reinvent every time. Use simple patterns automated by tooling. Again, these are patterns that once you've codified those for your organization, it's going to be very easy for you to spin up that next service or the next 100 services. It doesn't matter. You just keep adding resources and people can just keep shipping. And then self-service makes impossible things instant. This is one of the things that is, I think, most crucial is when you enable people to do self-service, when you get out of their way, they're going to do really interesting things. And the more quickly they can do those, well, the better it is for you and your company. And so, finally, you might be thinking, all right, well, how do I get started with this stuff? Like, there's a lot here. I've got a couple of resources for you. What I would recommend is you visit the Mesos website, mesos.apache.org. You look at the mesosphere.io/learn. That is probably one of the best, if not the best, resource for you to get started with. And then finally, if you're interested in deploying Mesosphere, which is another framework by a company called Mesosphere, there's interesting overlap there. They have this application they made for DigitalOcean at digitalocean.mesosphere.com, and that allows you to basically deploy a cluster of Mesosphere, the framework, on top of DigitalOcean, and it provides interesting. It's like basically like a private PaaS with all sorts of fun stuff like health checking, monitoring, and a whole bunch of other things. So I would definitely recommend that you check these out and go see if you start playing with it and see if you could make it work for your organization, because I think there's a lot to be gained from using something like this. So that's all I had. Hopefully you guys learned something, and I'd be happy to take some questions if you have any. Questions, anyone? Yeah, go ahead.
I have a question. Are you guys using Mesos internally in DigitalOcean?
Not yet. It's something that I think several of us have been experimenting with, including Brian over here. He's been doing some really great stuff, and I think there's a lot of good use cases that we could use it for. So I think that it's very likely we'll start seeing Mesos at DigitalOcean eventually. You had a question? Yep. Well, let's see. The Mesos cluster slave node is basically a C++ process that you run. So it's very efficient. Basically none. I mean, it's very small. So I wouldn't, like if you run something. I mean, it's negligible. I would not worry about that. I don't think that's in the grand scheme of things, it's really it's nothing to worry about. Yeah, there's one of the things I didn't get into is that a lot of the frameworks have various different constraints that you can apply on how you deploy. You want your application to deploy. You can say, I only want one instance of this, or I want 3 instances of this, but they have to be on different machines and things like that. So there's a few other projects that are in this space that also do similar things. Like there's a Fleet from the CoreOS guys, and I believe Kubernetes from Google is also sort of doing some of the similar things. And actually, you can use Kubernetes on top of Mesos to run, to kind of get best of both worlds. So there's some interesting technology and things happening in this space right now, which is one of the things I wanted to talk about it, is because it's getting very easy to do this stuff, basically. Anybody else? Yeah.
What happens when the master goes down? I mean, who gets notified how it's used?
So let me go back. So in this case, it depends. If you're running just one master, well, you're going to lose your cluster. But if you're running 3 masters, like they recommend in production, with a Zookeeper quorum, basically what happens is if one of your masters die, the Zookeeper, it'll disappear from Zookeeper. They're using Z nodes in Zookeeper, and one of the other masters will step in and basically continue as normal. So all the slaves will basically just switch to that other master. And so it's made to be fault tolerant, so you don't actually lose your operations while that happens. There may be some stuff that you lose, but very small. It's made to basically outlast like outages and things like that.
Some sort of an eventually you run 3 and then.
Right. Yeah. It's basically, that's the idea, is that your cluster should not go down because you lose one machine, because that happens all the time. And they do actually, the masters do themselves have a level DB file that they write their state or some of the state into, so they don't, even if they crash, they won't lose everything. They'll actually come back and they'll be able to recover from that. And I think the same thing goes for the slaves as well. So they actually try to persist some of the stuff that's in flight, so you don't lose things. Anybody else? Yeah. Let's see. If that was the one we had in New York 1, that what happened there was the data center, and I think we released this in the public announcement as well, but what happened was the data center, actually their backup power did not come on. And so unfortunately, there's really very little we can do at that point. Basically, we lost all power because they didn't, and that was very unfortunate. That's one of those situations that should not happen, but like I said, things happen. Stuff happens all the time. Like hardware and software fails, even if it's designed to not do that. Anybody else? Cool. All right. Thanks very much.